Listen, ZL equal to the load impedance equal to the ZL equal to the 100 plus J100, and characteristics impedance is the 50 ohm. So first of all we normalize the impedance. So normalize impedance ZL equal to the ZL upon Z0. So 2 plus J2. So value of R is 2 and value of X is 2. So first of all we mark this point. So value of R, so this is the R equal to 1, 1.2, 1.4, 1.6, 1.8 and 1.2. So this is the R equal to 2 circle, right? Now value of X equal to 1, 1.2, 1.4, 1.6, 1.8 and 1.2. So this is the X equal to 1.2. So this is the intersection of R equal to 2 and X equal to 2. So this is the normalized impedance ZL bar equal to 2 plus J2. Now we draw the VSWR circle by taking center at 1 and radius. So this will be the center, right? So we draw the VSWR circle. Now we draw the VSWR circle. So this is the VSWR, and so this is the VSWR. VSWR voltage standing wave ratio circle 1. Right? Now from this point we calculate the admittance. So how we calculate admittance? Just join the this point and this point and join this point. So this is the admittance YL bar, and we call it as A, right? Now in the question it is given that the first stub, listen, this is the transmission line, value of impedance is, load impedance is given 100 plus J100. This is the first stub. Location of the first stub from the load is 0.4 lambda, and the separation between the both stub, this is the second stub, and separation between the stub is 3 lambda by 8. Right? So this is the length of the first stub LS1, this is the length of the second stub LS2. So we have to calculate LS1 and the LS2. Now this is the separation between the load and the first stub. So this is the length. So if you convert into the angle, so angle equal to 2 beta L. 2 value of beta is 2 pi by lambda, value of L is 0.4 lambda. Lambda will be cancelled, so it will becomes 1.65. So if you convert into the degree, then it becomes 288 degree. 288 degree. If you convert it, it becomes 288 degree. So we will move. Listen, we are moving from load to source. So we move in the clockwise direction on the VSWR circle from point A. So from this point to this point 180 degree. Now we have to move extra 108, right? So this is, if we extend this point, So this is the up to this point 180 degree.
180.
Now we move up to this point, then 30 degree.
30 degree.
Now only we have to move 78 degree. 78 degree. Listen, this is the 70. This is 80. So in between, okay, 1, 2, 3, 4, 5. So 5, 10, 2. So 1, 2, 3, 4.
78 इधर हाँ
78. ये 70. This is the 78. 78. देखो 72, 74, 76, 78 है 78. So this is the 78. So we will join
this point is center point.
center point. Okay, and we mark this point as a B. We mark this point as a B. We mark this point as a B. Now we mark this point as a B. Now we draw constant resistance circle passing through the B. Now we have to draw the constant resistance circle passing through the B. So this is the constant resistance circle. This is the B. So listen, this is the constant resistance circle. आ रहा है क्या कैमरा में? हाँ. This is the constant resistance circle. So this is the constant resistance circle. This is the constant resistance circle. We mark this as a constant resistance circle, right? Now
सही फ्री हैंड ही बनेगा ना?
हाँ, फ्री हैंड यहाँ पे है, सर्कल डॉटेड लाइन दिया हुआ है, जस्ट आपको डार्क करना है, ओके? कहाँ से ले जाना है उसको? Now listen, separation between two stub is the 3 lambda by 8. So if we convert into the degree, then 2 beta L. 2 beta 2 pi by lambda, L is 3 lambda by 8. Cancel.
3 by 2.
1.5
pi.
यानी 270 degree. 270 degree. So we will rotate unit circle. Listen, this is the unit circle. We will rotate unit circle by the 270 degree. So if we rotate 270 degree, then 90 degree at this point, 180 degree at this point, and 270 degree at this point. So what is the radius? Total length is 0.5. So 0.5. How to draw 0.5? This is the one. This is the one. Just draw the straight line. Now calculate the 0.5 just at this point, and 0.5 here. Okay, this is the 0.5. We take 0.5. Now cut this point. So this will be the center. And now draw the circle. Now draw the so this is the unit circle, right? Now we mark the point intersection of the constant resistance circle and the unit circle. So see, this is the constant resistance circle. This is the constant resistance circle. And this is the unit circle. So this is the intersection. We mark it as a B plus, right? B plus. Now we draw the second VSWR circle by taking center at and radius at B plus, and draw the this is the VSWR circle 2. Now we mark the point of intersection of the second VSWR circle and the unit circle. So see, this is the unit circle, R equal to 1, and this is the VSWR circle. So intersection of point is this point. So we mark as a C point, right? The impedance at the C point is, see, this is the intersection of the unit circle and the VSWR circle. So at any point on the unit circle, the value of R will be 1. So it will be 1. And now we calculate the
J.
reactance. So see,
0.4.
no, see, this is the 3, and this is the 2. So it is in between here.
2.75.
So it 2.6 or 2.7. Okay, 2.7. So this is the 2.7. So it becomes C plus 1 plus J 2.7. Now we will take the mirror image of the C. So this is the
3 minus
2.7. So it becomes minus 2.7. So it is the 3, 1. This is the 3. S 1.4, 1.2. See, this is the 3 and this is the 2. So in between 2.7 minus 2.7. So we will just okay. Now we calculate the position at this. What is the position? 0.25 lambda, and this is 0.31 lambda. Now we subtract to calculate this length. We subtract. So this is the length of the first stub. Length of the first stub, L1. L1 equal to 0.31 lambda minus 0.25 lambda. So it becomes 0.6 lambda. 0.06 lambda. So length of the first stub will be 0.06 lambda. Now we have to calculate the length of the second stub. How to calculate length of the second stub? This is the B plus and this is the point B. Both point are on the constant resistance circle. So value of transconductance will be same because both are on the constant resistance circle. Now value we have to calculate constant. We have to calculate reactance. So this is the B. So this is 0.9 and this is 1. So it becomes 0.8 lambda. 0.8, and at this point this is the 1.8. This is the 1.8 and this is 2. So it is between 1.9. So what is the difference? 0. Suppose B minus B plus minus B equal to 1.9 minus 0.8. So 1.1, right? This is 1.1. 1.1. हम लोग ये वैल्यू कैलकुलेट करेंगे. So this is 1.2 and this is 1. All students, 1.2 and this is 1. So in between 1.1. So separation will be 1.1. So separation will be 0.8. Lambda 0.8. Now we have to mark the point 0.8. So here is the 0.8. See, this is 0.7 and this is 0.8. So it is 0.8. Right? So we mark. This is 0.8. Okay. So we calculate this length. LS2. Where LS2 equal to position at this is 0.25 and at this position 0.39 and 0.395. 0.39 and this is 0.4. So in between 0.395. So what is the
39395
lambda minus 0.25 lambda? If we subtract, then 5, 4, 1 lambda. So LS2 equal to, so this is the length of the second stub. In this way, we calculate the length of the first stub and length of the second stub. आएगा सभी को सुनो. Listen, in the question, it is given that separation between 3 lambda by 8. If it is given that separation is lambda by 8, if it is given at that question
It
with
will be 90 degrees.
see, space is lambda by 8. So if we convert into the angle, then it becomes 90 degree.
and
So this
circle
unit circle will come at this point. Okay. In this case, the position of the first stub is not given. So the point A and point B are at the same point. Point A and point B are the same point. Because a value of L will be 0, then the angle will be 0. So वहाँ पे 288 आ रहा था, तो यहाँ पे क्या आएगा? 0 आएगा. वो point at the same position. If the space is not given, between the two stubs, so by default we will assume 3 lambda by 8. क्वेश्चन में दिया हुआ है, देखो बहुत सारे क्वेश्चन है उसमें दिया हुआ है. In this question, terminating impedance is ZL 60 minus JT. इसमें it is not given the space between the two stubs or the position of the first stub. कुछ भी नहीं दिया हुआ है. So by default we assume position of the first stub at the load and the separation between two stubs is 3 lambda by 8.